Now, we move to the third interconversion of temperature scale, which is the Rankine and Celsius scale. Now, still using our interpolation rule, we have our Rankine minus 492, which is the lower fixed point, divided by our higher fixed point, which is 672, minus 492, which we have here. Now we move to the Celsius scale, our Celsius minus 0, which is the lower fixed point, divided by our higher fixed point, which is 100, minus our lower fixed point, which we have here. Now, we subtract R minus 492, we have here 672 minus 492, we have 180, equal to Celsius minus 0, we have Celsius, and 100 minus 0, we have 100. Now, what do we do next? We cross multiply. Now, we use 180. We cross multiply. We use 180 to multiply this, and we use 100 to multiply this, which we have here. 180 degrees Celsius, which is 180 times degrees Celsius, equal to 100 in bracket Rankine minus 492, which is 100 times this. So what do we do next? We divide both sides by 180, which you have here. So 180 and 180. 100 over 100 divide 180. So what can we use? We can use 20 to divide. So 20 in 100, we have 5. 20 in 180, we have 9. So our degree Celsius equal to 5 over 9, which we have here in bracket Rankine minus 492, which we have here. Now, we have derived our formula for converting Rankine to degrees Celsius. So, any question you see, they ask you convert from Rankine to degrees Celsius. This is the formula that we use. Now, from our equation still, from this equation, we can also derive our formula from degrees Celsius back to Rankine. So from this our equation, we say we divide by 100. We divide by 100. So 180 divided by 100. So we use 20 to divide. So 20 in 180, we have 9. 20 in 100, we have 5. So here, 100 cancel 100. So we are left with 9 over 5 degrees Celsius, which we have here, equal to 100 cancel 100. So we are left with Rankine minus 492, which we have here. Now we are looking for Rankine. So Rankine equal to 9 over 5 degrees Celsius plus, when this minus 492 cross to the other side, it becomes plus 422. Now that is how to derive the formula for converting from degrees Celsius to Rankine. Now let's take some examples under Rankine and degrees Celsius. Example 1. A hot body measures a temperature value of 80 degrees Celsius. Determine the temperature in the Rankine scale. Now, we use the formula for Rankine that we derive from the interconversion of temperature scale. So, our formula is Rankine equal to 9 over 5 degrees Celsius plus 492. Now, what is our degree Celsius? From the question, our degree Celsius is 80. So, we say 9 over 5 in bracket 80, then plus our 492. Rankine equal to, now what do we do here? We divide. So we say 5 in 80. 5 in 80 is 16. 5 in 80 is 16. So we have 16. We have 16 here. Plus 492. So our Rankine equals 9 times 16. We have 144. Then plus our 492. So our 144 plus 492 equals to 636. So that is how to convert from our Celsius to our Rankine. Now let's use the same question to convert from our Rankine back to our Celsius. Now we use the formula for converting to Celsius, which is degree Celsius equal to 5/9 in bracket Rankine minus 492. Now, what's our Rankine? Our Rankine is 636. So we say degree Celsius equal to 5/9 636 minus 492. Now what do? We find solution to the bracket. So we subtract what is in the bracket. 636 minus 492. So what do we have? This is 4, this is 4, and this is 1. So 636 minus 492 is equal to 144. So our degree Celsius equal to 5/9 in bracket 144. Now what do we do next? We use 9 to divide 144. We have 16. So we say 5 in bracket 16, because 9 in 144 is equal to 16. So our 16 times 5, that is 30, that is 80. So our final answer for degree Celsius is 80. Now this is, we have converted from our Rankine back to our degree Celsius, and it still gave us our answer, which is 80, as you can see in the question. So that has to convert from Rankine back to degree Celsius. So now we take our number 2 question, which says, if the temperature of a metal rod is 600 Rankine, determine the temperature value in degree Celsius. So what do we do here? We use the formula for degree Celsius, which says 5/9 in brackets Rankine minus 492. So what is our Rankine? From the question, our Rankine is 600. So we put 600 here. So we say 5/9 in bracket 600 minus 492. Now, we solve for the one in bracket first, according to our board marks. So 600 minus 492 is equal to 108. So we say 5/9 in bracket 108. So what do we do next? We divide. We say 9. We divide 9 and 108. So 9 here, 1, 9 here, 12. So we can see 12. 9 in 108 is 12. So which we have here. So we are left with 5 and 12. So 5 times 12 is equal to 16. So our degree Celsius in this question is 60. Now we can also convert. Let's convert our degree Celsius back to Rankine using the same formula for Rankine. So Rankine, we have 9/5 degrees Celsius plus 492. Now, what is our degree Celsius? Our degree Celsius is equal to 60. So we say Rankine equal to 9/5 in bracket 60 plus 492. So what do we do here now? We divide. We divide. So 5 in 60. 5 in 60, that is 12. That is, so we have 9 in bracket 12 plus 492. So what do we do now? We multiply 9 by 12. So we have 108. So our Rankine is equal to 108 plus 492. Then adding the both of them together, we have 600. So our Rankine is equal to 600 for this question. Now we take some examples on resistance in temperature. Now in solving resistance question, we have two ways of solving it. We can either use the formula or we use interpolation rule, the rule that we have been using to interconvert from one temperature scale to another. Now we'll be using the two rule in solving some questions. Now let's take the first question. If the resistance of the element of a platinum resistance thermometer was 4 resistance at 0 degrees Celsius and 5.46 resistance at 100 degrees Celsius, then the temperature of the platinum resistance scale that will convert to a resistance value of 16.8 resistance will be. Now, to find resistance, we use the formula R theta minus Ri over R100 minus Ri, where R theta represents what the value they gave us, 16.8. Ri represents the lower fixed point, which is our lower fixed point, that is 4. As you can see, they say at 0 degrees Celsius. So lower fixed point for Celsius is 0 degree Celsius. So we have 4. That will be our Ri. Then our R100 will be our higher fixed point. Our higher fixed point here is 5.49. As you can see, at 100 degrees Celsius. This is our higher degree Celsius for degree Celsius. So our resistance will be 5.46 for our R100 minus our Ri, still the same thing as our lower degree, lower fixed point. Now, so we use the formula to solve this question. So our R theta, like I said before, our R theta is 60.8 minus our Ri, which is our lower fixed point here, which is 4. So we have minus 4, divided by our R100, which is our upper fixed point. Our upper fixed point here is 5.46. So which we have here, minus our lower fixed point, which is 4. Then multiply by 100, as you can see in the formula. Then we solve 16.8 minus 4. We have 12.8. Then 5.46 minus 4. We have 1.46. Then times 100. Now we divide 12.8 divided by 1.46. We have 8.767. Then multiply by 100. So our 8.767 times 100 will give us 876.7. So that is our final answer for solving this particular question. Now I said we can use two methods of solving resistance. Either we use the formula or we use the interpolation rule. Now we have used the formula to solve this question. Now let's use the interpolation rule. Now if you remember our interpolation rule, where we say our interpolation rule like this. So we are using resistance and degree Celsius. As you can see, they use degree Celsius here. They use degree Celsius here. So we are using resistance and degree Celsius. So what is the upper fixed point for our question here? Our upper fixed point is 5.46. As you can see, 5.46 at 100 degrees Celsius. So we use 5.46 here. Then we are looking for, we know we are using resistance. Our resistance is 16.8. So our lower fixed point is 4. 4 resistance at 0 degrees Celsius. So our lower fixed point will be 4. So we are using that against degree Celsius. So our higher upper fixed point for degree Celsius is 100. Then this is our degree Celsius. Then our lower fixed point is 0 degrees Celsius. Now, using our interpolation rule, We said 16.8 over minus 4 divided by our upper fixed point minus our lower fixed point, which we have here. As you can see, 16.84 divided by our upper fixed point, 5.46 minus 4, which we have here. Then equal to our degree Celsius minus 0, which is our lower fixed point, which we have here, and our 100 minus 0, which is our upper fixed point minus our lower fixed point, which we have here. Now we subtract 16.8 minus 4 is equal to 12.8. Then over 5.46 minus 4, we have 1.46. Equal to degree Celsius minus 0, we have degree Celsius. Over 100 minus 0, we have 100. So our degree Celsius is equal to 12.8 over 1.46 times 100. If you want to simplify it, you can just cross multiply 100 here, then 1.46 degrees Celsius, then you use 1.46 to divide both sides. So 12.8 over 1.46 will give you 8.767, then times our 100. So our final answer will be 876.7. So as you can see, we got the same answer as the answer we got when using our formula. So let's take another example on resistance. This question says the resistance of the element of a platinum resistance thermometer is 2 resistance at ice point, 2.73 resistance at steam point. Remember, our ice point is our lower fixed point, and our steam point is our upper fixed point. Now, the question says, what temperature on the platinum resistance scale would correspond to a resistance value of 8.43? Like I said before, we can use two methods of solving resistance. We have the formula method and the interpolation rule method. So we use the formula method first. So our formula for finding resistance, we have the R theta minus Ri divided by our R100 minus our Ri. So what is our R theta? Our R theta in the question is 8.43, which we have here, minus our Ri. Our Ri is our lower fixed point. Our lower fixed point here is 2. As you can see, 2 at ice point. Remember, ice point is our lower fixed point. So we have 2, which is there. Then our R100 is our upper fixed point. Our upper fixed point, where's our upper fixed point here? Our upper fixed point is 2.73, as you can see, at steam point. So this is our upper fixed point, which we have here, 2.73. Then our Ri is still our lower fixed point, which we have as 2, so which we have here. Then times 100, as we have in the formula. So what do we do next? We subtract. So 8.43 minus 2, we have 6.43. Divided by 2.73 minus 2, we have 0.73, then times 100. So 6.43 divided by 0.72, we have 8.8082, then times 100. So 8.80782 times 100 will give us 880.82. Now, this is the answer to this question using the formula method. Now, let's use the interpolation rule method. Now, as we know, our interpolation rule we are solving this question with respect to our degrees Celsius. So from the question, the up one, we take this one as the resistance scale. So what is our upper fixed point here? Our upper fixed point here is 2.73, which is here. So we write our upper fixed point here, 2.73. Then here we have 8.43 8.43, we take this one as our 8.43. Then our lower fixed point is 2 at highest point. So we take 2 as our lower fixed point. So in our Celsius temperature scale, we know that 100 is our upper fixed point, then 0 is our lower fixed point, then our degree Celsius. So using the interpolation rule, we say 8.43 minus our lower steam point over 2.73 minus our lower fixed point, which we have here. We do the same for our Celsius scale. We have Celsius minus 0, which is our lowest fixed point, then 100 minus 0, which is our higher fixed point minus our lower fixed point, which we have here. Then we subtract 8.43 minus 2, we have 6.43. Then over 2.73 minus 2, we have 0.73, equal to degree Celsius minus 0, we have degree Celsius. Then 100 minus 0, we have 100. So what do we do here now? Here we cross multiply. We have 6.43 times 100, which we have here, then equal to 0.73 times our degree Celsius, which we have here. So we multiply 100 times 6.43, we have 643, equal to what we have here, 0.73 degrees Celsius. So we are looking for our degree Celsius, so we divide both sides by 0.73 here. So 0.73, we cancel 0.03. So we are left with 643 divided by 0.73. So our 643 divided by 0.73 is equal to 880.82. So that is our final answer to this question using the interpolation rule. Please, if you have any question regarding temperature, please you can put it in our comment section below, then you'll be responded to. Thank you.